Okay, so just to go over some of our work with SOHCAHTOA and right angle triangles. So the first thing is a right angle triangle has three sides obviously, and we can name each of those sides. So the main side, the most important one, is your hypotenuse, and we always know where that is because it's opposite the right angle. The hypotenuse is also the longest side, and we know it's the longest side because in a right angle triangle, the right angle has to be the biggest angle. So all the angles add to 180. So if there's a 90-degree angle, there can't be another angle that's bigger than 90. So the hypotenuse is the longest side, it's opposite the biggest angle. Okay, so similarly to that, the shortest side would be opposite the shortest angle. So there's a relationship between the side and the opposite angle. Okay, and there's a ratios for each of those. That's where SOHCAHTOA comes from. So in order to be able to use SOHCAHTOA, we need to know the other sides as well. Now the other sides depend on which angle we're using. So if we're using this angle in the bottom right, then we look first for the side that's opposite. So this side here is opposite the angle in this case. Then the third side is called the adjacent side. Now adjacent means beside, and there are two sides here which are technically beside the angle. You have the hypotenuse and the adjacent side, but we've already labeled the hypotenuse, so we're not going to call that adjacent as well. So we have our hypotenuse, our opposite, and our adjacent. Now, if we are looking at a different angle, let's say we're interested in this angle instead. Now, that is the opposite side because it's opposite the angle that we are using or the angle that we're interested in. So that one is the adjacent. So based on the angle that you're interested in or using, you will either be using it or trying to find it. You can label the sides. First, label your hypotenuse, opposite the right angle. Next, label the side opposite the angle you're using. And the last one is the adjacent. So, as I said, there are ratios. There's a relationship between a side and its opposite angle. Okay? And in a right angle triangle, there's some special ratios. So, we have one that's called the sine ratio, which is the opposite side to the hypotenuse. So that ratio for any right angle triangle, doesn't matter what size the triangle is, the ratio of the opposite side to the hypotenuse will always be the same. And similarly, for the adjacent side to the hypotenuse will always be the same. And the opposite side to the adjacent side will always be the same. So we've named those three angles sine, cosine, and tangent. Okay? There's an easy way to remember this. We use SOHCAHTOA. So the sine is the opposite over the hypotenuse, or in other words, S equals O over H, SOH or so. The cosine ratio is the adjacent to the hypotenuse. In other words, C equals A over H, or K. And the tangent ratio is the opposite over the adjacent, or in other words, T equals O over A, or TOA. So using SOHCAHTOA, we can identify which ratio we are going to use. So let's look at an example here. The first thing I want to do is to label my sides. So the first one I'm going to label is my hypotenuse, and I can see that here's my right angle, so opposite the right angle is the hypotenuse, so that's H. Next, I look at my angle, the one I'm interested in or using, which is 62 degrees here. So opposite that is my opposite side. And lastly, the third one, the only one left, is the adjacent side. So I've now labeled my sides, and I will be using two sides and the angle. So let's look for which two sides am I using. Well, I'm looking for X, which is the adjacent side. So I'm going to be using the A, or the adjacent. I have the hypotenuse, which is 9, so I can use that, and I know the angle. So to start with, until you get used to it, you can write down your SOHCAHTOA. Now it might be actually better if you write it down like this. S is O over H, C is A over H, and T is O over A. So go through your SOHCAHTOA and see which one uses A and H. So what some people like to do is, I need A, so there's an A and there's an A, and I'm using H, so there's a H and there's a H, and only one of the ratios will have both ticked. Or the only ratio that has A and H, adjacent and hypotenuse, is the cosine. So I am going to be using cosine for this one. So I can nearly ignore my opposite side if I like. So the first thing I would do, again, if you're used to it, you can skip this step, but write down the cosine of the angle is equal to the adjacent, I should say. The adjacent over the hypotenuse. Now I'm going to write in everything that I do know. So the cosine, the angle is 62, and sometimes that's written with a bracket, equals the adjacent, I don't know, but it's called x, over the hypotenuse, which is 9. So what I'm left with now is an equation, okay? It might look a bit more simple if it was something like 3 equals x over 9. Okay, but it's still an equation. We just need to solve it to get the x by itself. Okay, so cosine of 62 is just a number. Okay, when I put that into my calculator, so if I put my calculator and press the cos button or cosine, and then type in 62, it gives me 0.4694 or something like that. Okay, now to save me working with big long decimals, I'm going to leave that calculation until the end. But what do I do to get my x by itself? I need to multiply both sides by 9 to get rid of that fraction. Some people say we bring the 9 across and multiply. I like to say we multiply both sides by 9. So if I multiply both sides by 9, I end up with 9 times cosine 62 equals x. So once I do this calculation, 9 times cosine 62, I'll put that into my calculator and it gives me 4.2252 with a load of more decimals after it. Now my question says 1 decimal place, so I'm just going to round it. So x is approximately equal, that's what those squiggly lines mean. It's a rounded answer. 1 decimal place will be 4.2. Now there's no units given in the question, so I don't need to put units. So pause the video for a second and try that one yourself. Okay, let's quickly do this one. So I'm going to label my sides first. Here I have the hypotenuse is opposite the right angle. This is the angle I want, so x is the opposite side, and the last one then is my adjacent side. Okay, I can scribble out my h because I'm not using it and I don't have any number there to use. So I go SOHCAHTOA. I'm using the adjacent and the opposite, so O and A. So that's my tangent ratio. So let's write down the tan, for short, of the angle equals the opposite over the adjacent. Fill in what I know. The tan of 38 equals the opposite over the adjacent. I need to get the x by itself, so I'm going to multiply both sides by 8 to get rid of that fraction. So what I'm left with is 8 multiplied by tan 38, and that gives me x, the value of x. So in my calculator, 8 times tan 38. Now in your calculator, just be careful to close any brackets that you need to close, or it might give you an error. That gives me 6.25028 and loads more decimals equals x. So if I want to round that to 1 decimal place, it's 6.3. Okay, let's look at another example. This time, I have sides and I need to find the angle. So we have this symbol here, which is a Greek letter called theta. And theta is basically just another variable, so you can change it to an x if you like. But theta is usually used for angles. So instead of x's, we use theta to identify that it's an angle. But we're going to work exactly the same way to start with. So this is the angle that I'm interested in. Firstly, my hypotenuse is there, opposite the right angle. The angle I'm interested in is the theta. So that is the opposite side. And the last side is the adjacent side. So I go through my SOHCAHTOA again. And as you get more and more used to this, you can probably do this without even writing it down. H doesn't have any number, so I don't need that. So I'm looking for the ratio that uses A and O, which is my TOA, or my tangent ratio. So again, for short, tan of the angle is the opposite over the adjacent. Fill in what I know. I don't have the angle this time, so I'm going to use my theta. That equals the opposite is 6 and the adjacent is 4. So the problem now is my angle, my variable that I want to get by itself, is stuck inside this tan. So how do we get it out of there? Well, we need to kind of just think about our equations for a little bit. Let's say we had 6x equals 24. In order to get the x by itself, or get rid of the 6, we need to do the opposite. So this means 6 times x, so we divide by 6. If we had, let's say, 20 divided by, x divided by 5 or something, equals 4, we'll say. To get rid of this 5, to get the x by itself, I multiply. So I do the opposite of dividing. The same concept applies. So we need to do the opposite of tan. Okay, or in other words, the inverse. So tan inverse is written like this. Tan with a little power of -1. And that means inverse of tan. We can do the same for cosine and sine as well. Another word for some of these, which you might see, wouldn't come for us very often, but arctan is the same thing, or arccos, or arcsine. Okay, but usually for anything we're working for the leave insert, it'll be tan inverse, or tan to the power of -1. So I need to do tan inverse to both sides. If I use inverse tan on tan theta, I just left with theta. Then I have tan inverse of 6 over 4. So in your calculators, you'll see your tan button, and then above it, in a slightly different color, you will see tan inverse. So to get the inverse tan, you need to press shift and then press tan. Don't hold shift, just press it once and then press tan. So if we do that, we press inverse tan and then type in the fraction 6 over 4, or if you want to change it to a decimal, you can, and it gives us the answer theta equals 56.30999. It goes on for a bit. Again, we want 1 decimal place in this particular question, so I'm going to round it to 56.3 degrees. Okay. So go ahead and try this example yourselves. All right, once again, I'm going to label my sides. I will move a little bit quicker this time. So this is my hypotenuse. It's opposite the right angle. This is my opposite. It's opposite the theta. And I'm not going to bother with the last one. So in my SOHCAHTOA, I'm looking for a ratio that uses O and H, or opposite and hypotenuse. And the only one that does is sine. So I'm going to be using sine. So I'm going to write sine of my angle is equal to the opposite over the hypotenuse. What I do know, I don't know the angle, so I call it theta. That's equal to the opposite side, which is 7, over the hypotenuse, which is 10. Again, I need to get the theta by itself. So I'm trying to get rid of this sine. So I need to use sine inverse. And then I need to do it to the other side as well. So what I'm left with is sine inverse 7 over 10. And in the calculator, shift, then sign, then put in the fraction 7/10. Close any brackets you need to close, and I get theta is equal to 44.427 with a couple of decimal places after. So to one decimal place, it's 44.4.